One more inequality. So we've got another inequality, but this one is a quadratic inequality. The first thing that we want to do is get everything on one side. We absolutely could think about this graphically as a line and a parabola. And what this is asking us to solve is find all the x values for which this line here is below or equal to that parabola. So if we would, I mean, it's probably not what it looks like exactly, but we can kind of make a rough sketch of what it sort of looks like, right? So what we want is all the values for which the line is on or below the parabola. So that would be from here this way and from here this way, right? So all of our solution set in this case is going to be here and here and on. But this is, you know, a little more complicated than we want to deal with. So we can make our lives easier by just scrapping this whole idea and thinking about this in a little bit different way. If we move everything to one side, we could do that. So we usually want to have this be positive. So let's have this be positive. So we got 0 less or equal to, because we're just going to subtract these things from both sides. So we got 2x squared minus 5x minus 4. So we just subtracted these two things from both sides. Okay, so now this question becomes, where is this parabola above 0? Which is essentially just where is it above the x-axis. So if we drew a picture, just a real rough sketch again, hey, here's a parabola. What we want to know is where are the x values such that this parabola is above 0, which means, hey, it's above the x-axis, right? So we can do it, right? As long as we have 0 on one side, all we really need to do is find these x-intercepts. So we can do that. Let's do that. We can do that. So we're really just going to solve this and find out where it's true. All right, so solve. I don't know where I was going with there. Maybe I do. Solve 2x squared minus 5x minus 4 equals 0. Right, so we want to solve this to find our x-intercepts. And we can do this pretty quickly. Either we should use we can use the nice quadratic formula, or we can try to factor. Factoring is usually easier. If we can factor, we absolutely want to, but maybe we can't, you know. So in either case, we've always got that nice quadratic formula that we can fall back on. So why don't we just do that? So we know that solutions to this have to be of a certain form, right? Right? Okay, so we know that this is true, and probably don't have to explain what we're doing so much. We're just taking, you know, here's A, here's B, here's C. We're gonna plop it on in there. We've done this before, hopefully. So negative B, so we want negative 5, so that's a positive 5, plus or minus square root of B squared. So we can kind of do a couple steps at once, right? B squared, so that's negative 5 squared, it's 25. Then we got minus 4 times A times C. So this is going to be minus 4 times A times C. So that's 8 times 4 is 32. And that is going to be positive, right? Minus 4 times minus 4. So we got plus 32. And then we divide by 2 times A, so that's just 4. Okay, so now we got a little bit of simplification to do now. 5 plus minus square root of, what is this, 57. Boy, none of that really worked out that great, did it? I mean, it worked out fine, but it's just ugly. And, well, sometimes they're just ugly. Anyway, we can do this now. So we've got our intercepts. So going back to the graph here, this is really all we wanted. So we wanted to know where is the parabola above the x-axis. So it is outside of those points, right? So if we would look at our intercepts, the positive one is going to be this one, and the negative one is going to be this one. So we want to be Our solution set is everything left of the leftmost one. So we got negative infinity all the way to 5 minus square root 57 over 4. And then we have a non-strict inequality, so we're going to use a bracket because we can equal 0. So if I put that in, it's going to equal 0, right? Okay, so now this is everything left of our left x-intercept, and we want now a union with everything to the right of our right x-intercept, right? We want everything, all the x values for which the parabola is above the x-axis there. So we got 5 plus square root 57 over 4 all the way to infinity. And that would be our interval. It is absolutely ugly looking, and we agree on that. If they can factor, usually they're not so ugly, but sometimes we have to deal with ugly things.